Hi everybody, I'm Lamberto Basti, and today we're going to see how to write some build logic in Kotlin and and do things the right way. So let's start with a little introduction of myself. What do? Well, I work at JetBrains, and I work in the package search team. And the package search would be a plugin in IntelliJ to handle the dependencies for JVM projects, at least only for now. And it will edit directly Gradle, the Gradle build file, or the Maven POM XML, or the SPT build file directly from the UI. So check it out for updates and Google it for more information. Now let's go to the topic. So normally when you want to build when you want to write some build logic for your project, you either at some point rely on some scripting languages like the Bash or the Bat for Windows. But when the actual build gets more complicated, you wanna go on CI and stuff, you soon realize that the scripting is it's not gonna work that well. And then you start relying on something more complex like Python or JavaScript or eventually Groovy, even with Gradle. And then with those languages, you have the fact that it's not really clear how you should, handle them always. Like, do I need to put a variable here? Okay, is that correct? Does that variable actually exist here when I'm doing it? You can only know when running them, not before. So let's try to fix that. We'll try to fix it by using Gradle, but this time with Kotlin. And when using Kotlin, a lot of stuff gets better. And let's first see some of the Gradle goodnesses. Well, of course, there is Kotlin. That's why we're here. And when you're using Gradle, you can write your build logic. You can pack it up in a library. You can even publish it on Maven and then reuse it later in another project. And when using Gradle, you are completely OS independent. You don't need to, explain to your colleague that is using CentOS to, whatever reason, it would just work. And then when using Kotlin with Gradle, you have IDEA support. So you can use autocomplete, you can use refactoring, and much more that you're used to when working in Kotlin. So without further ado, let's go for a live demo. We're gonna talk about how to wrap your web server into a Docker image, and we're gonna see that in how to do that in Kotlin. So let's start. Okay, so let's start with the project structure. It's a fairly simple project structure. We got a simple main file. That's it. That's the whole project, and there is the build file that we're gonna see in a moment. So let's see what's inside the main. Okay, inside the main, we got we're using Ktor, which is a web server library, I'd say, from JetBrains. It actually allows you to write very neat DSL in Kotlin to define a web server. And it's actually pretty neat. For example, let's see in this one, we are creating a server, exposing it at port 8081, and we configure the routings so that when we receive an HTTP GET in the root path, we will just print the caller host in the command line, and then we're going to respond to the caller with just some text written hello KotLand and word, right? So let's see how it works. We are inside IntelliJ. We got this nice run button. We click it run, and some magic will happen somehow, somewhere. Let's see. Issue build. Eventually. Come on. Do it. Yes. Okay, it's working. So it is running. Let's put some soft wrapping. Is it? Yeah, okay. And let's try to get to localhost 8081. And there we go. It works. Let me zoom a little so everybody can see it. As we can see, hello localhost, which has been written. And every time I reload here, 1, 2, 3, we got other 3 prints. Okay, that's nice, that's great, but we are on our machine, so we need to pack it up inside a Docker container. So what we're gonna do is that we're gonna close the main file. We're gonna start seeing what's inside the only build.gradle.kts file in the root folder, because this is, of course, a Gradle project. So this is a pretty straightforward build file. We got the latest Kotlin plugin installed for JVM. We just set up the group and the versioning. We are getting all the libraries for the dependencies from Event Central, because from where else? And we just imported the Kto server itself, because yes, we need that, and some library that Kto needs to, write this neat, logging stuff in cool ways and stuff. So, and that's it. Now, the first issue that we need to solve is, before even talking about Docker, is that, well, we need to run our application, but we don't have IntelliJ on, on our barebone system or cloud server or whatever. So we need to pack it inside like an executable. And there is a plugin for that, and we can just use it. So we look for the plugin application, and we can even look for autocomplete. As you can see, it works because we're inside IntelliJ, and that's Kotlin. So we load the configuration, so that some black magic of Gradle generates some accessors for us without actually, evaluating all the script. It's just going to evaluate this line, to be precise. We need to wait for it to finish. There we go. And now, magically, we'll have available the application closure. Okay, so inside this closure, we need to tell the application plugin which one is the main class. So let's see, what's the name of it? Oh yeah, it's main class, right? So we use the setter, and we say to it that the main class has the fully qualified name of main.kt. Please remember that when compiling the Kotlin, unless you specify a class name to a file, all the functions would be inside like a virtual, class that is called like the source file. So in the case, the file is called main, so it will be called main.kt. So now the application plugin is set up. We sync to get all the information, the latest information for IntelliJ. And if we go to the Gradle section here, we can see that magically some tasks have appeared. To be precise, the one that we'll be using would be distribution zip file and installation disk. This guy is actually pretty cool. When running it, it actually compiles all the projects and put it all inside a zip file, right? Which is this one that we can see open in Finder. There we go. That we can see that in this zip file, sorry if it's little, we got all the libraries that the project is using, which are those ones, and even our project that is compiled here in a jar file. And we got two neat script files, one for Unix and one for Windows. And when we run this one, assuming that we got the JVM in the path or the Java home variable, environmental variable enabled, we run it, and there we go. The project is working. So we go here, run it, and yet again, it's working. As you can see, localhost. Okay, that's nice. We got a way to actually run this thing without IntelliJ. So, okay, cool. There is another task here that I mentioned. It's called install dist, which actually extracts the zip for us, so we don't have to do that manually. So when we run this one, you go inside the install folder here, inside the build folder, and you will see that the files have been actually extracted for us, right? So that's great. Okay, nice. So we just gotta now put all these things, well, actually those two things, inside a Docker container. And how do we do that? Well, to do so, we need to use a Docker file, right? So here we go. We got a nice and neat Docker file already ready. So this Docker file is pretty straightforward. It uses as a base image the adopt OpenJDK 11. It copies the bin folder that we just mentioned here, those two in the app folder. And the same goes for the lib folder. Then we have that it exposes the part that we're using, and then we gotta run the script. Now, at the moment, the name of the script is the name of the project, and the name of the project can be changed from this variable here inside settings.gradle.kts. So we don't want to hard code the name of the project, right? We want to pass it when building it. So we're going to use a build argument during the Docker build execution to pass the actual name of the script that we want to run. But that argument gets stored only during the build time. So when running it, you won't have access to this variable. So you got to store it somewhere else in the meantime, and you can store it in the environment. So you store the environment, you put as a default this guy here, right? And then you just save it. So when you get to run it, it just works. Okay, right, nice. So we could build our Docker container the terminal, but if we would do that, we wouldn't be here right this talk. So let's do it with Gradle and some Kotlin. So one thing we want to do is we want to use the Gradle tasks to do so, and we use the tasks closure of Lambda, and we can see that inside of here that this will be a task container scope. This scope is actually a pretty particular class we're going to see later. But what we're going to need to understand here is that we can create what is called a task. So a task is like an action that we want to let Gradle execute. In our case, a context like a folder where we copy inside the bin folder, we copy the lib folder, and we also copy the Docker file, right? Because Docker needs all these three to actually work, and they needs to be in the same folder. So we're going to do here, we're going to write a Docker prepare task. So let's see what's here. The registering function that uses delegation from Kotlin actually gets the name of this guy, of the variable itself, and it will be the name of the task we can use. The type of the actual task that we need to use, it's called sync, and that sync, it's just let's see, synchronizes the contents of a destination directory with some source directory and files. It's just like the copy task, except the destination directory will only contain the files copied. Okay, nice. It seems what we need. Nice. So we're going to say that the group is Docker, and the group is like this folder here, this little folder, just for humans to organize stuff better. And then we're going to say that we're going to copy the Docker file. And what's that? Well, this is a sync, a task provider of sync. Okay, so it's this guy. It's this guy here. But how can we have it available here? Well, turns out that when using Kotlin for Gradle, some black magic happens, and some tasks, not every task, but some tasks gets automatically receive an accessor generated for us. So we can use the autocomplete of IntelliJ to actually get them. And that is very nice. And also this from function, actually it's very smart. It understands a lot of things. In that case, when you pass a string, it automatically looks for a file or a folder that has that name in the same place of the current build file that you're using. But instead, when you're passing a reference to a task, to another task, in that case, the task is actually outputs, or bin and lib folder, it will automatically look for the output files of this other task, like automatically. So this is just wraps up all that we need. And we're going to put all together inside the build there, which is this one here. It's a variable because it's actually changeable, so we're not going to change it, but it's changeable, so it's configurable, so that's why it's a variable. And then we decide to put inside the Docker folder, and then we're going to give the name to the latest to the last folder the same of the name of the project, and in that case would be this one here, right? Because we are in the root project. Okay, so we sync it to see what happens. We open Gradle here, and okay, we got a Docker group. We got a Docker prepare task. We're going to run it. And what happens here is that a Docker folder gets created. It got the name that we want. Yes, that's correct. And we got all the files that we want. Okay, that's nice. That's really nice. Now we can call inside of here Docker build, right? Yes, but again, we're not going to do that by hand. We're going to let Gradle control Docker itself. Now, we will give for granted that we got Docker installed on our machine. Actually, I do. So that one requisite for that to work. So let's keep on. I create val Docker build. Okay, that's a lot of code. Let's go a little by little. Okay, so we can see that we have created a variable that it's called image tag, which makes sense. We need to give a tag to the image that we're going to build. And it would be the project name with the version of the project, which is this one. Okay, makes sense. And now we create a new task, like with registering, that would be called Docker build. But this time it's not a sync because we don't need to copy file. We need to execute some application, some command, right? Some executable. And that executable will be Docker itself, right? Remember that the group is Docker, so it's neatly packed up for humans to read. And what's that? Well, this is a function that tells Gradle that when you're building, you need first to prepare the context of building, right? Because otherwise, there are no files to invoke Docker build on, right? And then we're gonna choose the arguments that we want to use for the actual executable. So of course, it's a build, Docker build. -d is to give a name to give a tag to the image, of course, and it's going to be this variable here. And then remember that we need to pass.
Lamberto, I'm sorry. You
Hello?
disappeared for like 30 seconds.
Okay.
Could you please get back to the executable part and start from there again?
Part. Here, I was here, right? This guy.
And now you are disappeared again.
Oh God, I don't know what is happening.
We don't know yet. Well, okay, let's try without your camera. Now you can see your IDE. That's fine. Yeah. We can see IDE. Let's continue.
Okay, you can see the exec, right? I was here.
Yeah, we were on like executable line.
Okay, so we need to pass the list of arguments to Docker, right? So there is this function here available in this exec class. Let's just briefly recap what an exec task is. Executes a command line process. Okay, that's perfect. It's what we need. And we're going to do the list of build, which is the command, the first command that we're going to pass, -d, then the image tag that we're going to, pass it. The build arguments, which we remember that we need to use kind of a hack here to let the name of the project gets inside the Docker file, right? So the build arguments will be arg app name equals project.name. Okay, makes sense. So we pass the project name to the Docker file during building. Okay. And then the last argument should be the actual path of the folder where we copied all the stuff. So we have Docker prepare, we save it here, we get the actual task, and the actual task, it's a sync task, and it has a function slash property from Kotlin that returns the directory to copy the files into, and it's a Java.io file. So we put it the absolute path of the file, and that's nice. Okay, so let's sync to get all the stuff here. And we're gonna see Docker build appear magically. Okay, we run Docker build, and as you can see, Docker prepare gets executed first, and then Docker builds all the stuff magically. There we go. Yes, as we can see, it has first compiled all the stuff, and it has evaluated if it actually needs to run the tasks again or not. In that case, nope, because the files were already here. Gradle is pretty smart about trying to understand if a task is already been run or not. So we should expect in the services here an image called, oh, there we go. It's the right one. We can create a container. Okay. we need to bind ports, because otherwise, how do we reach it? 1. Okay, we run it, and unless I made some mistakes, and I hope not. Okay, so the actual containers is running. Okay, so we go here, run it again, and yes, it's working. So, okay, we're gonna stop the container because, yeah, because otherwise the port will remain active. And in the meantime, the containers get stopped. We're gonna see something else. Like right now, I run my image by hand, but we can make Gradle run the image for us, right? Like we got the exec task. We can do it again. So let's go for Docker. Oops. Exactly, it's Docker this one. Okay, so a little more code. We're gonna save the name of the container that we want to run. We're gonna create a task to actually stop that container if it's running, right? So it's again an exec task. The executable is Docker, and it stops the container with that name. And if Docker doesn't find the container, it's fine anyway. I mean, we just need to stop it. If it's not there, who cares? And then we register another task called Docker start. Don't let you distract from the fact that this is registering, this is registering. This is used when you don't want to save it into a variable. When you want to save it into a variable, you got the by registering. Okay, that's basically the same thing. So we create a task called Docker start that actually depends on building the image and stopping the other one if it's there, right? And we call the executable, it's Docker, of course, and you run, you remove it when it got stopped, so it doesn't remain dangling. We make it detached, so it doesn't keep Gradle running. We give it the name of the container, which remember is the name of that variable, and then we expose the port because we need to expose the port. And then we give the image tag, which is the one that has been used to build the image, which is this one, right? So I sync it. I hope that everything is good. I wait for IntelliJ magic to happen. And there we go. We got Docker start and Docker stop. I click Docker start. Yes, there is no daemon. And oh, well, it's running. Okay. I click this one. And yes, it's working. And now we're going to do something really great. We're going to iterate pretty quickly into this one. We're going to just delete this one. And now we're going to start Docker start again. And this time it's going to re-trigger yet again the building of the project, repacking of Docker. It will stop the image. It will take quite a moment because I did not implement the listening of a kill. Okay, there we go. Now we update it, and there we go. We got the latest one, and the Docker container is actually running, and we can see it here in services. Here we go. It's this one. Nice. Now we're gonna stop it this way. It's gonna pretty soon die. As we can see, we were inside the container because we got the local host of the Docker VPN. Eventually we'll die. Eventually. Oh, there we go. It's gone. Okay, nice. Now we know how to automate a lot of stuff, but that would be pretty handy if you got only one project in your life. But what if you have many projects that uses Gradle and you want to use that logic yet again and again and again? So for that, we need to create an actual plugin. To do so, there are many ways in Gradle to do that. One of those is to create a build SRC, and it's the easiest one. So we're going to do that because we have a little time. So a build SRC is a special folder, build SRC, that needs to be called that way when using Gradle, and needs to have a build.gradle.kts file in it, right? And as soon as we create that file here, Gradle is going to recognize this folder as a special build, a special project, and everything that it's got builds inside of here will be available inside the script here. So we're going to understand in a moment how that works. The first thing that we need to know is to actually write some build logic for that other project. I have it already written, and there we go. So let's ignore the Kotlin Lambda here, and let's ignore this one here yet again. We're gonna get back to this one in a moment. Let's wait for Gradle to do its magic and for IntelliJ to do its own. And yes, it got recognized as a project, and everything lighted up like in Christmas. Nice. Okay, so the first plugin that we installed is the Kotlin DSL. This plugin actually allows us to create a project that can host, where you can write a plugin for Gradle in Kotlin. And then, since this one packs the Kotlin 1.4 plugin, we're gonna override it by putting the latest one, because why not? Okay, so let's start writing some code, right? We go into new, we go into directory, we create the C main Kotlin like always, because this is just a normal Kotlin project. We're gonna create a package. We're gonna call it com.github.lambda92.evilbash.gradle. There we go. We got our nice long package like we always do in the JVM, and we get a file, a class actually, and we call it Docker plugin. Nice. So what's a plugin? A plugin is just something that extends. Oh wait, plugin, and let's add all the imports. Imports. Nice. It's a plugin of what? Plugin of project. Okay, and of course it is like wants us to implement a lot of stuff. How was it? It was this one. Okay, so it wants us to implement this actual function, which is the only function that we need to implement. So we're going to receive the actual project that needs to be configured. And remember, for those who doesn't know, that this in a script file is the project itself. So all of those like functions that I call, they are all functions of the project. So basically, we're going to configure the project from here instead from here. Okay. So since we're in Kotlin, we can use neat stuff. So let's use it. Thanks, standard library. Okay. Now this would be the project itself, and so we have kind of the same DSL that we have. Now, before going on, we need to understand something of Gradle. That something is extensions. Okay, an extension is just an object, like just a plain object that's been created in a particular way, like initialized in a particular way. But the object itself is just a class, just a normal class. So let's write one. Normally, when creating an extension, the name of the class is whatever you call it, extension. So we are creating a Docker plugin, so we will call Docker extension. So class Docker extension. So we're gonna go back in this one in a moment. And this Docker extension is just a one-line class because yes, we are in Kotlin. Thank you. And needs to be open. It needs to be open because when creating this one, Gradle is gonna do some dark, deep magic and needs to modify the bytecode and stuff. We don't care. It just needs to be open. Just leave it open so it compiles. That's it. And then here, the only variable, the only property that we're going to need in the constructor, because I decided so, because I want it there. Otherwise, you can put it wherever you want. Remember, this is just a normal class. Would be, okay, for now, let's say this is a collection. To be precise, this is a hash map of string Docker image. And Docker image is this other class we're going to get in a moment. Okay, so if you're not convinced about that, let's just see. We got IntelliJ. Thank you. Okay, so we can see that this guy extends this other guy that also extends this guy that is a collection. Oh no, sorry. Yeah, and there's also a set. So trust me when I say so. This is a map. This is basically a map that every item has a name, right? So the Docker image is the value, and the key is a string, and it's a name. And also, it is very much good practice to save the key inside the object itself. So let's watch this guy here. This guy here indeed got the private val name, and it extends this this simple, very simple interface that only has get name, that gets the name. That's it. Now, the rest of all this stuff, it's actually the information that we need to collect to build the image. Like a Docker image, what does a Docker image has? It has a version, it has an image name, it has the build arguments, which is basically a map of string, and the container name that we want to use to run it. And this guy, we're going to get this guy in a moment, but this guy is basically the lambda that is used to let the developer specify which files goes into where. Now, we also I'm gonna tell you that these two classes are the actual APIs that will be available here. Okay, so first of all, let's will be available in the build script. So how do we make them available in the build script? Well, the first thing that we're going to do is to create the extension. How do we do that? Well, we save it, ext equals extensions. Remember that this inside here is project. So this extension is a property of project. Extensions dot create. Okay. And this create is going to need some stuff. It's going to need the first one would be the actual no, sorry, the type. When it needs the type is Docker extension. And the first value is the name of this extension. And this name will be the one that will be used in the build script for a project. And we're going to call it just Docker. The second value is the, yeah, that's also some pretty dark magic stuff. Here we got a var arg. It's the last one, var argument. Those are the things that gets into the constructor of the class. So in that case, we need to pass this guy here. So we're not gonna construct it by ourselves. There is Docker APIs to do so, and that API is called container. So function, well, in Kotlin it's just a function that it passes us the name of the Docker image that we are building, and we're gonna return it a Docker image. So it's a Docker image, right? So what do we need here? We need the name equals name, what else? Then the version, we're gonna use the project dot version dot to string, yeah, because legacy stuff, it's not a string, but it's actually a string. And then we're gonna use the actual, oh, sorry, I clicked something that I shouldn't have clicked. Goodbye. And then the last version, the last thing is the image name. What name should we give to the image? Well, let's just go for the name that the user actually gives us. So we're gonna use image name equals name itself, right? Okay. So, okay. We created this extension, right? It was a pretty packed stuff. So before using it, let's see what actually doing that stuff here is gonna causes us in the build of Gradle KDS. To expose this plugin here in our actual project, we need to go in the build src here, go in the build file, and use this one, this Gradle plugin lambda, open the plugin's declaration and register a Docker plugin. We're gonna give the name of the plugin and we're gonna tell them, yeah, you know what, this is the actual class of the plugin. This is the class of the plugin, right? So when using the Docker plugin, just use this class. Okay, in the meantime, I've synced, and some magic has happened in the background. Some magic that allows me to do here. Look, Docker. Oh, what do we have here? We have a plugin. Okay, well, let's just use it. Okay. Sync it. And we're not going to need the tasks anymore. Bye-bye. Because we're going to let the plugin do the task stuff that we just did previously. So now, since I created a Docker extension with the name Docker, a Docker Lambda is available here. And this is actually that guy that I created here. Oh, nice. Okay. So inside here, since this is a Docker extension, I expect images. And those images is here. Yeah, it's here. I can open parentheses, and this is actually a pretty neat stuff from the, Kotlin operator overloading, which is using the invoke function, but it's long stuff. If you have time, just go read it. But it's dark magic. It works. And what we're gonna do here now is that we can use the Gradle API to create those guys here. Okay, so remember, in here, the developer is just telling us declaratively what kind of image we want to build, right? And what kind of image we want to build and how it is like what we're going to put inside the image. So let's see a moment. Okay, so what we're going to do here is going to register an image called production, because imagine that you want to decline your software for, I don't know, production and staging, because in production, you connect to a database that you save the environmental variable, and in staging, you connect to something else. And for production, I will give the image name because of production, project name.production, and for staging, for staging. When using register, it is much like tasks, right? I do tasks. I can do register, I don't know, my new task, right? And this would be a task. And since this is a register inside the tasks, and this is a register inside the images, this is going to be a task, and this is going to be a Docker image. That's the magic. Oh, sorry. That's the magic of Gradle. Okay, so let's collect. Now we have collected some information, and since we are using Gradle, we can use the magic Gradle name it domain object container scope APIs, which are a huge name to say, yeah, that's a collection. Okay, yeah, it's a collection. And we can use something like this function here, let's call all, that is basically a lazy for each. Like once all the things got registered and created, this thing will be applied to each Docker image. We're going to say that the version is 42. We're going to say that the actual context used for the actual folder used for building the image should contain the Docker file and what's inside the install this task, right? Let's dive in a moment in how this guy works here. Just very, very briefly. If we go to context, because yes, we have navigation, IntelliJ is smart enough to follow us into the declaration of the plan. This function is just, it just takes a lambda, well, not a lambda, a functional interface called action. We can't use Kotlin lambdas, not because it won't work, it will actually work, but because if someone from Groovy want to use our plugin and we use a Kotlin lambda, things will go horribly wrong. If you use an action, Kotlin will understand that you're trying to be nice with your Groovy fellows, and it will convert it automatically to lambda. But use actions. So we're going to use like an action of this guy here. Who's this guy? Well, remember when we created the sync task? Well, that sync task actually was a copy action. And the API for the copy action, if you remember, we use the from and the into. And those two APIs, those two functions are not declared in the same interface. One is declared into the copy interface, the other in the copy source spec. And this interface here, we're gonna follow it, just has the from function. That way, we can just expose the from function here. So the user that is consuming our plugin will not be able to decide where to store those information, just to say how to build the actual folder for the context. And it's pretty nice because you don't want to overload your plugin user with just information that it actually doesn't even care, right? And also getting back in here, the last thing that we need to pass is the build arguments, because remember, we need the rgap name for stuff. And this is just a map. Actually, this is a reassignable map. It's a var. So we just assign it with map of our gap name to project. Thank you again, Kotlin standard library, for having neat stuff. And now, basically, when I sync, what happens? Well, nothing, because literally nothing, because I just created the extension, but now that I've deleted the other tasks here, there won't be tasks here as soon as the builds finishes. Have you finished it? Yeah, there won't be any tasks. So we need now, given the images that are those images here, given those images, we need to create a task for each actual Docker image that we declared. Now, how do we know? Now we recreate this guy here, right? But how do we know that the user has actually used it here? Well, there is an API for that. This API is called after evaluate. After evaluate. This API actually, what does it do? Well, we can read it. Adds an action to execute immediately after this project is evaluated. What does this project is evaluated means? Project is evaluated means that this guy, I mean, all this guy actually, gets executed. So after that this guy gets executed, so we actually add to the images collection the production element and the staging element. Inside of here, the extension .images.forEach, because yes, remember, this is a collection. Data image. This is a collection, and inside of here has been consumed by our plugin user. So it's filled. I mean, we hope it's filled. I mean, what's the point of applying the plugin if you don't use it? But anyway, now inside of here, we're gonna create a task for each staging or production or whatever he registered. Okay, so how do we do that? Well, the same way we did in the build script. So we're gonna do it like docker prepare, but this time will be just slightly different. Okay, so the difference will be that we just need to create a task for each one. So the task needs to have a specific name, like Docker production prepare. And since this is a for each, one decapitalized name will be production and once would be staging. So we create two tasks: Docker staging prepare and Docker production prepare. And what does this do? Well, it's going to go into builder Docker, the name of the element that we created. Which name? This guy here, 1 and 2. So we expect here that something like Docker. This can be deleted now. Docker production and Docker staging will appear when we invoke the tasks. And how do we know which stuff to use? Well, remember that this guy here is a copy spec, and a copy spec is also a copy source spec. So this guy here that we used earlier has saved how to configure that guy, and it is saved inside an internal variable with a default that it's just do nothing unless you override it. And what happens here is that we execute, because execute is the actual, remember, this is just a simple function. It executes that stuff against the D's, which is just the sync task right now. So we sync it, reload all the stuff, and some magic will happen. The Gradle runtime will recompile our project, will add this project to our build script, and when we run all the stuff. And unless I made some mistakes, let's see. You can do it. There is some mistake? No. Okay. What are you doing? Maybe it's done, but it isn't. Oh, okay, it's done. Yeah. for reasons IntelliJ decided not to finish. But okay, so we got the Docker production prepare and Docker staging prepare as we know it. And we run the Docker production prepare. It runs all the stuff. Okay, we go in project, and there we go. We got the production stuff. Nice. We go here, we go in Docker staging prepare. We go in project. Oh, there we go. We got this stuff. Nice. As we can see, they are the same. Why are they the same? Well, because, yeah, for both of them, I use the same information here, right? So if I would do something like, I don't know, here, and this other guy, I'm gonna do like Docker file, and then I'm gonna, I don't know, add even the sources for reasons, the staging, because I don't know, I sync it, and now this time I go for Docker staging prepare, and Docker staging. Oh, there we go. Main Kotlin lib the file itself. We won't even use it during the Docker build file, but it's good to know that whatever we want to add into the context, we can do it pretty easily actually. Okay, that's really nice. Okay, so we won't do it because why? And now, what else? We need to actually build the stuff, and we're gonna do something very much similar to the thing that we've done in the build script, which is var docker build. Okay, so that's more stuff than just the Docker build. It's going to see as long as we have time, but we have time. So the Docker build is yet again an exec task. And we're going to create a Docker production build and the Docker staging build, right? Because we're inside the for each here. And so the data changes, right? And the capitalized name is still this guy here. Okay, so we need to make the Docker build depends on the Docker prepare of the previous stage. But this guy is going to be, if this is staging, this is going to contain the Docker staging prepare, and this is going to be the Docker staging build that depends on the Docker staging prepare. So right, that's correct. We're going to use we're going to put the group Docker, and the executable will be Docker because yes, we're going to run Docker. And well, this guy here, you see it, it's lying. It's actually lying because the exec task has a lot of set args overloads, and it even has the args argument. And from time to time, IntelliJ and the compiler, the Kotlin compiler doesn't really quite talk to themselves. And one says that you can use the accessor, the other one says no, you can't. So just go for the function, and you won't have issues like lay low, you know. Then we're gonna use the build list this time because we need to build programmatically the list. So we add the build.
Lamberto, I'm sorry, we are a bit out of time, like 4 minutes. Let's try to wrap up it in couple 3 minutes, okay?
Okay, yeah.
Thank you.
Yeah, basically here it's the same that we've done earlier, but just decline for the two images. And basically that's it. Now we just sync it. And here it's gonna appear. Yeah, exactly. We do a Docker production build, Docker production prepare, Docker production start, and Docker production stop. We got just for the Docker production start. And it will just run our container. No, there is a little error. Oh, damn it. There is a plugin that has stopped working. Full access deny repository. Oh, well, anyway, there is just a little error inside of here. Like, I think the dash has not been cleared. But basically, it would just work. All the information is also available to the GitHub on the Evil Bash KotLand repository, and that's it. So for whatever question, just follow up in the Q&A session. Thank you for following me.